Okay, Mr. Pham, go ahead.
Mr. Pham, you need to unmute your mic. We can't hear you.
Hello, Mr. Pham.
Maybe you have to call him on the phone.
Yeah.
Unmute your mic.
Okay, sorry, I mute up. Now you hear it, right? Sorry.
Yes, we
Yes,
hear
we can hear you.
Okay, so now I will rerun the test of student name Magpali Dente. Here is the test program. Okay.
Want to share your screen, sir?
Oh, let me share it now. You see it?
No. There we go. I changed the value already, so I resubmit it.
Okay. So, Dente, you failed test number 7.
Try to rerun again. Stop
Okay.
at the name before you start.
Okay, we run it again now.
Yeah, to make sure they read the name.
That's your name, right? The failed test number 7. Test number 8. And you passed 9. Fail number 12. Number 15. And number 16. Okay. So Dante, you have to correct your program and upload again.
I corrected it and resubmitted, re-uploaded.
Okay, so I will
Just a
check
while
on
ago.
that one next time.
Okay, thanks.
Now I'm going to run another student test. Okay, this test looking good. The next one
How come I didn't see the name?
Let me see. It's why its name it passed too fast now. He didn't put a name in here. Okay. I will rerun this one with the correction, okay? This program passed, but we have to go back and then adding 2 lines here. That is a program buy and then post. You need to put that 2 line in your program.
How come that line is not the right one?
Okay, I see it's a last name here. Okay.
So if he already know, then the program that already passed it, he fix it again.
Okay, this program is passed. So okay, you hear me?
Yes.
Okay, now go back here and then we run the program again. Where's name?
Mute. We cannot hear anything.
Okay, now coming back. You hear me, right? I pick up another program here. This is another student program. Name is Du Susanna.
So Mr. Pham, that's how you want them. You want the name at the top, right?
That's right. And you put a programmer that at one line, and then the second line is a pose. You call it pose function.
That on the one I already put it in the Excel.
That's right. I see a lot of students, but some of them missing.
Just copy that and change something for the test.
I was copy, but the one he have it in there is wrong. He put his name in there, so that's why. I had another program. Test number 1. Jennifer Petit. Okay. I compiled. I already ran it. So now I just make sure to show you step by step how it runs. And this is a lab number 1. And later on, I will run to verify test number, lab number 2. I have a 6 program of a student on the lab number 2, but we have to finish the number 1 first. Here come another program, B lab 1. This program, instead of it put the EET, so I changed it to ETT. It's no name in here. This program of Mr. Jose Rubio.
Yes, that's my program.
Yeah, you forget that line. I already checked, and then I didn't know where it go. I add that program line in there, but it's not showing here again. But this is your lab, Rubio. Very
Yes.
good. It passed.
Thank you.
And I believe you have a lab number 2, and later we'll see. Okay.
Yes, I did too.
Here come another program. Mr. Joe Smith. Oh, Mr. Smith, it's program, the lab number 1 here, you don't have your name, but I will run it. Okay. I will run it anyway. Now, here we go. Next time, put that 2 line in there. You have a lab number 2. I believe that lab number 2 have it.
No, I agree with you. I thought it was already pasted in by your brother, but I'll have to check.
And
Which one is this, lab 1 or
lab number 1.
number 1? Okay, I'll check to make sure those names, that line go
That
in.
line in there, that 2 line must be in there.
Okay,
Okay.
yeah, I know what you're talking about.
Yep. That is a simple. And another program here.
Do you see that 2 lines in there?
No, I don't. And I was correct that, but when I save, I save the one, it's not updated.
Oh, okay.
And this one also.
Yeah,
Yes.
because it's got to have that pause in there. Okay, I'll fix those anyway. Even though they pass, I'll fix them no matter what.
Yeah, yes. And now let's try see too many of them is missing that one. Why too many of them? Okay, I run this program. This program is this program good, Mr. Jeffrey Medi, lab number 1. It should be look like this one. Press any key to continue.
Yeah.
Okay, I'm going to run another program now. Here's a new program. I just add this line in there, so it's so, okay, now continue to run. That's good. Now I'm going to run another program, lab number 1. This program belongs to Santos, Juan Santos. This is a good program. I'm going to run another one. This program belongs to Trend Google. Okay. Another program, one passing. Now I run another program here, and we will know who it belongs to. Let's say. This program belongs to Valaki Oscar.
It's me. It's me.
So this is an on of the lab 1. And I'm going to verify that lab number 2. So give me about 1 minute to change halfway, okay? And this is the lab number 2. Adam Pony. Let's say. Bill. So you see it showed up in here, D lab number 2. Name student and run. This one is the lab number 2.
Way to go, Adam.
Huh? This is Adam Pony. He already have a number 1 pass, and now he have upload number 2. It's also pass. And I have a 6th program lab number 2 to verify today. Very good.
Good job, Adam.
Thank you very much.
Adam's probably got all 4 of his done.
Now I'm going to get the another lab here. The lab number 2. This, the lab number 2, belong to Jose Rubio.
That 7 and 8 have a wrong tab number.
That it's missing the display tab number 08 and 09. So Rubio, you see that?
Yes, I guess I just missed this number there.
Yeah, just put that the 08 and 09.
Got
And
it.
now I have another program. Jose Smith. Mr. Smith, this program you have that line correct, so I'm going to build and then I run it.
Mine goes slow. It's thinking, do I want to pass him or do I want to fail him?
No, this one very good. You did a good job on the first 2 laps.
Okay.
Okay, I'm going to run the next one now.
God, Mr. Smith.
All right.
I got 3 more programs to run. The lab number 2.
Have you finished all the DLab 1, Mr. Pham?
Huh?
Have you finished all the DLab 1?
I finished on up the lab number 1 already upload. Is that maybe your upload, but I haven't run yet?
Yeah, I didn't see mine run, so I just wondered.
Okay, tell me what's your name.
Last name's Liu, L-O-U.
L-O-U. I know. I know why. I will talk about that when I run your second lab number 2. Okay, now I run this one first.
Okay.
This is your lab, the lab number 2. And now student, this Mr. Lu Juk here, he upload the program and also he have a hardware to verify that one. He already run it past, but I only download the lab number 2.
Okay, all right, thank you.
This one is the lab number 1, right? Let me check and see how many program here, how many tests in here. I'm running number. This is number 2, but you are naming it right here, number 1. Okay, that is.
Yeah, I forgot to change it.
Because I know it. This is the lab number number 2, but when I look at in here, you see it.
Yeah.
Okay.
Check it.
Okay. That minor. You can correct that. Okay. You don't need to upload them.
Okay.
But correct it for yourself.
Okay.
And I will run. I will download number 1 to run it next time, Mr. Job. Okay.
Okay.
I see number 1 and number 2, and then all you already verified with your hardware. That's very good. Okay, and I have another DLab number 2.
Change the name. Oh, okay.
What is name here? DLab number 1. DLab number 2, Mr. Oscar. Okay, this is my last one. Okay, that is all of the lab verify tonight. 1 and 2, D lab 1 and D lab 2. Do I miss anyone? You already upload, but I haven't run yet. Okay, so thank you. Mr. Pham,
Yeah,
back to you.
go ahead and say it. Okay. So, did we try to show you the way the lab will be verified. However, in the future, we cannot do it. Lab instructor will be just try to verify your lab and just let you know part or fail. The reason is we have no time. Right now, the test will be less than 16 tests. It's okay. However, later on, you can get 32 tests, 64 tests, 256 tests, or 512 tests. Take a long time to run. Okay? So we cannot do it.
512
And
take all day, huh?
yeah, take a long, very long time. We cannot do it. Right now, we just let you know. That is the way we verify your program with the hardware. When it passed, that means next job will be you build the circuitry. Then you run with your program already good. Make sure it passed, then you're done. Okay, so the guy in Tech two, that means you already passed halfway on the program. Digital lab will be very, very important to you. The theory on the digital, not much. Next time, you can say you just learning the part, like, memory, how they working, DAADC, how they working, or different type. But that only thing is the IC, you know how to make it work, then you can write a program to test it. Okay, so everyone must doing your lab. In this program for Tech2, we get 3 different types of the student. First one, they already got complete, they already get a certificate. So I don't care. They still want to learn, that's okay. I don't care about any upload any program. Okay? The second student, that means you not complete to get a certificate yet. Even you start from last spring. But for the COVID-19 problem, that we still not done for the program. Then you must be upload, doing your program, upload it, okay? And the last one, that means you just take one last semester, now you take 2. Then you have to do it also. That is the way we able to prove with the city when I asking for a certificate, okay? Otherwise, we have to get something to prove it. You would done something. So if you get any problem, how to do the D-Lab, then you have to take to me. so I can help you by individual. Not too late now, but if we keep moving, then you completely get lost. Right now, we get number 1, number 2, number 3, number 4. Okay? So, today, I will be helping you to explain to you the lab number 3 and maybe the lab number 4. How can we do anything you don't know how to do? Okay, so any question, anything? No?
3 is the D flip-flop, right?
Okay. And now I will be go into lab number 3. If you still need something help on 1 or 2, then let me know. Okay, this is the lab number 2, number 3. First thing, you don't have to understand anything. Only thing right now, they're telling you, using PSPI simulation to run the simulated to this circuitry. Okay, simulation will be helping you if you give to them the input and they will be giving you the output. That's what you want, if you know how to do. So the first step is complete simulation. And in order to do the simulation, okay, I already given to you the input here. Okay, the input here, that means I given you the clock signal. I given you the preset signal. I given you the clear signal. Okay, then you have to using the include file to create that waveform to apply to that circuitry. Then you can run. So up to this point, any question or anything? Right now, I don't not talking about understanding the circuitry. I'm talking about simulation. You get any question? No?
So far, so good.
The thing is we're not using much simulation for the digital lab. The thing in the PSPI student version, we don't have enough part number. Okay, later on, The only thing you can do is understand how H1 working in order to testing, make it work.
Mr.
Okay.
Fan, one question regarding the PSpice student version that we are using. Is that a kind of old version or an updated version of PSpice?
No PSpice version we get. They don't have enough park in the library.
Even the last the most updated student version of PSpice?
You know, in the future, you mean the lab in the future, right?
Just I'm trying to ask you if the PSpice student version, the most updated student version, has all the parts that we need to build all to simulate all this DLab. Do you know?
No.
Okay, thank you.
Okay, now on this lab here, only thing you don't know is the flip-flop. Okay? AND gate, OR gate, or NAND gate, we already get through it. So now I'm talking about the D flip-flop. Let's see. How many input for that D flip-flop?
Four.
How many?
Four.
4, right? 3, right? Or 4? Okay, first thing, we're talking about a synchronous input. Okay, number 1, which one?
The clock.
Now, synchronous input mean what? Not depend on the clock. Okay? You understand the inside the computer or inside the digital circuitry, everything will be controlled by the clock. However, sometimes we don't want to depend on the clock. Flip-flop, that means they get one output queue and another will be not queue. We just deal with queue. If you know queue, you know not queue. Queue, they can be equal 1. Or queue can be equal 0. And not queue just inverted. Okay? So now is synchronous input. The first one we're talking about preset. Okay. Normally active low. Okay. That means preset equal 0. Then Q must be 1. Anytime if a preset 0, then Q must be 1. They don't care anything else. And the second one will be clear, CLR. Also active low. Okay? That means when the clear 0, CLR equals 0, then Q must be 0.
Hey, Mr. Pham?
Okay, clear, active low. Let's see. Preset active low means
Pretty
preset
much
equals
be
0.
wrong.
Okay?
When preset is low, then the output has got to be 1.
Right. Preset active low. That means preset equals 0. Then Q
To be 1.
must be 1. Okay? A second one clear. Clear active low. If clear 0, Q must be 0. That allows the designer, they can reset the output of the flip-flop to 1 or to 0 at any time they want it. They don't care what clock supposed to be. Okay? And also you make sure number 3, both preset and clear cannot be 0. At the same time. Okay? And number 4, for the clock operation. Both PRE, preset, and clear CLR must be 1. So that will be given you on of the information for the asynchronous input. If you understand, memorize that, that's why you know how to make it work. And if it's not working, you know how to fix the problem. If you don't know how they're working, how can we fix the problem? That is your job. Anything, if you're not quite following it, then you let me know. Okay, and now we go to synchronous. Synchronous input. Okay, so the first one, clock signal, CLR, CLK. Second thing, D input. Okay, now how they work. Q equal to input D when the clock going from 0 to 1 transition. Okay, without this transition, of clock, Q will be no jam. That is cover everything for this D flip-flop. You get any question here?
Can you upload that notepad file,
Upload what?
that text file to the the text file to the website?
No, the one I just given to you here,
No, the notepad, the notes.
the notepad, depending on what, you know, you're talking about. The notepad I just created,
Yeah, the stuff you were typing, the notes on the
that
Good one.
basically will be in where? In the handout. Okay?
Okay,
I will
okay,
go back to the handout for you guys.
okay, thank you.
Okay, now what I want to do, I try to see, okay, simulation for this lab. I try to finish that one before I going back into the handout. Okay, let's see. File. Here. That is the one. So I suppose you already know how to get into the PSPI and draw this circuitry. And now I try to display the include. Okay. This is the include here. Okay. I try to make it a little bigger. Okay, so the first one we're doing for the clock signal. Okay, and the clock signal, the only thing you only change the P clock in here. They will be matching with that inside the schematic. Okay. Then this at the beginning the 0 and 1 U, they will be 1 and you keep repeating. Okay. And the second one for preset, they will be low. Okay. If you're looking into here, I give it to you. Preset at the beginning the 0. 4.5 microsecond. Then they go to 1. They go up to here and they going low 4.5 microsecond, then they going high. Okay. So that's why you can see at the beginning 0.5 U they go 1. 11.5 U they go back to 0 and they stay in 0.5 U they go back to 1. Okay. And now the other one, last one will be the clear. The clear you can get, they will be 1 for how long? 1.5 U. Then they go low. You see that right here. They 1 for 1.5, going low 0.5. Okay. So this will be here. 0, okay. Second at the beginning, they want 1.5 U, they go to low. And they low for 0.5 U, they go back to 1. That's it. That only telling you, if they given you the timing here, you're able to write down in the include file to tell the program this is your input and they given you the output. Okay, and now I will try to run the simulation and show you how to collect the data. Okay, now let's see. Analysis here. Set up for in here, I already show in the handout. Set the final time to 28 microseconds. Okay, that's good enough to display on of the test you want. Then now you simulate it. Okay. First thing you adding here, thread here. Remove that one. You must think. Okay, now you want to display the clock first. Then preset. No, we want preset first. Okay. Then the clear. And output will be 1, 2, 3. Okay. If you get a different color, guarantee you get a wrong thing. It's supposed to be green. And now you want to collect it for output for each tab. Okay. Then you click on this fucking here. Okay. First thing they say test the clear. Then you're looking for clear 0 right here. See that? Preset. You test the preset. Click on the preset 0. Output will be 1 and 1 and 1. Okay. Then the next they say test for the clear. Looking for clear go to 0. Right here. That's why you get output on 0. And now you're testing for D. That means you must be going, clock going 0 to 1. Then you're able to collect the data. Right here. You see that? Clock going 0 to 1. After that, you can click here, 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 doesn't matter. Okay? Then you click in here, they're telling you, you get 0, 0, 1. Then the next step must be 0 to 1 transition. That means right here. You see that? You go like that. And you go, next one will be here. Okay? And next one will be here. And then they say, next one will be here, right? Then now you have to test the preset. Then preset 0, click 0. Then the output on 1. Then after that, you can go 0 to 1. 0 to 1. As much as you can to collect the data. You get that?
Got it.
Any question? Now, that will be done for page 5. I go back into the Excel. Okay. So, output in here. Okay, you collect output when you run the simulation. Okay, you get output PC 1, 2, and 3. Okay, that means right here. If it is a part, that means oh, you okay on this output here. Now, then you go to the port AC. For the port AC here, you know, I allow you to only enter in this area. This area, dark area here, that means you don't have to write to port A anymore. Okay, so the first one you can get, you want preset, then preset must be 0. And the clear must be 1. That's what like I just showed you. Okay, if you testing for the clear must be 0 and preset must be 1. Then you converting to the hexadecimal here. And now you start counting, testing for the clock, then both that one must be 1. Okay, and during testing for clock 1, 2, 3, 4, 5, you don't have to write to port A anymore. Up until here, they say, okay, I want that preset, then preset must be 0. Clear must be 1. And after this one, you test for the next clock here, then both have to be 1. Okay, so after you're done on this one, then make sure you put the data output into this part here. Okay, for Q0, Q1, Q2. That means for PC1, 2, and 3. And also now, what the math data you want. Try to understand the math data. When you tell the computer to verify output in the port C, computer will be read 8 bit, not only 3. Okay? And you want what? You want only pin 1, pin 2, pin 3. You don't want any more here. So that's why you need to map them out. In order to map them out, you must be enter 0 here, 0 here, 0 here, 0 here, 0 here. And the pin you using, enter 1. Okay? And now you converting to the height, then they will be 0 height. What number? 0,
7.
7.
7.
That's why here, 0, 8, 0, 7. Okay? And the peacock here, you don't have to enter anything for now. I already gave it to you. That only thing later on when you know what's going on, how to do the lab, then we deal with the problem. If the test number 1 failed, what caused the problem? Or test number 2 failed, what caused the problem? So you enter all of data here, change it to the hexadecimal. If they say part here, that means you're okay. Now, that is done. We're not talking about the quiz, okay? That means you will be ready to code it, okay? Then this time I already gave to you the test program here. You see that? The test program here, you just copy Control A, right? And paste it into your project. Change what you need to change. However, I'm not giving you all of the test. Then after the test number 3, then you must be adding the test number 4, 5, 6, 7. Okay? In order to do it, only thing what you need to do is deal with the port ABC only. Forget about the circuit. Now you, for example, they say you will be I enter the test, what test number here? The test I given to you is test number 3. Okay? And you will be adding more test number 5. Now, on test number 5, you don't have to write anything to port A. So forget it. And you go into port C, number 5 here. That means you just read port C and you want data will be 0.5. Okay? So if I have to do it, then I just copy that number 3 here. That is that number 3. Copy and paste them out here. Okay? Change that number 3 to that number 4. Okay, that clock, whatever, that clock number. Okay, then you can go to that number 4, that clock number 3. We on that number 4, that clock number 2. Okay, then that one. Number 2. Expect data, I believe 0.5. Just from the port C. Okay.
Semicolon.
We don't need to write to port A anymore. Okay.
And
So
Mr.
take
Pham,
that.
Mr. Pham, you forgot to put you deleted your semicolon.
Okay, that doesn't matter. You have to do. Okay. That one, right?
Yeah.
You just copy in your program. That's more easy than I do in here. Okay. Now, you still apply the clock. Then you no changing here. Nothing you can change in here. That's what I said. The code, this following code cannot be changed. So that's why you can done for that number 4. If you want to do it again, copy to do number 5. Okay, and put in here. Okay, and you change that to number 5. You change that title here. You change the expect data here. Okay, then the rest will be cannot be changed anyway. You see that? Take not too long. You can run the test program very easy.
Hey, Mr. Pham, can you go up top real quick so I can see where that name was at? I wanted to see what that looked like.
Which one?
Up top where you said don't change it about the name or something? Further up.
Let's see. Right here, right?
No, the name. Like, remember when your brother said, oh, you didn't put your name in the program or something?
Here, right?
Oh, the pause. No, line 30 and 31.
Okay, 30 and 31 here.
Yeah. That's what you want. You don't want that changed.
Yeah.
That's all I wanted to know. Okay, line 30 and 31.
The thing is later on, we not verify on the lecture section. We have a no time. However, the other instructor will be run the program. They know who. Okay. belong to that program, so he can recording and let you know part of it.
Okay, thank you, thank you.
You are welcome. So that is a very easy to complete the D lab. Okay. You have to understand, nowhere in the United States get a technician class teaching you the way we do it. Even you can go to the city college, Mesa College, if they do have. The thing is, the instructor in the city college, in the university, they're not working, okay, in the company. I've been in the company for 27 years. Okay, so I know what technician in the company is supposed to do. That's why we create a different way in order to helping you. When you're working as a technician, you know how to do what to do. And if you're doing good, go ahead and go to the college university, a few years later, you can be an engineering.
Mr. Pham?
Yeah.
I have a basic question about the preset. I feel that I understand well the clock and the clear, but not the, what is the job of the preset? Could you please explain a little bit more, maybe using the circuit that you have on the Excel sheet, about what the preset is doing? Could you please do that?
What the preset
is doing? Yeah, I don't understand well what preset is doing in this circuit.
Okay. Now I'm going back to the schematic here. If you're looking on the timing here, okay?
Okay.
You see the preset 0.
Yep.
Then the clear mode be 1.
Yep.
And the preset 0, what happened? That means on of the queue here, pin 5, pin 9.
Should be 1.
They must be 1. That is the job for the preset signal.
Okay, basically that is the main job of the preset signal.
Right.
Okay.
For
You.
example,
Okay.
everything on this flip-flop here, 1, 2, 3.
Okay.
The output Q will be equal to input number 2. Only the clock will be going 0 to 1. Okay?
Okay.
And Q can be equal, pin 5 can be equal to pin 2 in here. However, preset and clear here must be 1. Either 1 equal 0, then Q can not working with the clock signal. Okay, so now I will be going back into the handout. Okay.
Okay. Basically, what Mr. Pham is saying, when you get pre and clear, pre is 0, Q must be 1, or Q is, clear is 0 and Q must be 0. That's like an override.
Right.
Override is like the other rules don't make any difference at that point.
Right.
When you see pre is 0, Q is 1, no matter what, or clear is 0, Q is 0, no matter what. Those are overrides.
Right.
Okay, okay.
That means they override everything.
Got it, got it.
Just a minute, I turn it into my iPad.
And the other condition that the Mr. Fan mentioned is when pre is 1 and clear is 1, D is equal to Q, right?
Q, you know, D, Q equal to D only.
Yeah. Only when pre,
Only clock going 0 to 1.
okay.
Let's see, I need to stop there on this guy. Let's see. Okay, let's see. Take 2. And now combination last. Okay. Now you see, okay? We're talking about the flip-flop. That will be D. Okay, that they're talking about the flip-flop. Now, what the difference between the flip-flop and the logic gate? This is the gate AB. What gate is it? Y equal A times B, right? AND gate. Okay, you get a 1 here. You get a 1 here. What out?
1.
1. Okay. Now, if I going to change that to 0, what out?
0.
It is 0.
0. Okay. So this is a logic gate. Whenever you change the input, output will be changing. Right?
Yep.
Okay. Now, what's the difference between the latch and the flip-flop? I'm talking about the D flip-flop. Okay, you get the input D. You get the clock. and you get a Q. Now, if you get a D equal 1, when you get the clock going from 0 to 1, then Q equal
1.
1. Okay?
Yep.
If I change the input D equal 0, what Q?
Should be 0.
Okay? What Q equal? Q still be equal to 1. Okay?
Okay, got it. Thank you.
Until you want to change, then you must be apply the clock. You see that?
Yes.
That is the difference with the logic gate. That means the flip-flop, they can store the value here.
Okay.
Until, okay, you want to check. Okay? Now,
Yes.
each flip-flop, they will be a 1 bit in your computer memory. So they can store the 1 or 0 as long as you want. Okay?
Mr.
Even
Pham,
they can change whatever here, doesn't matter. Q cannot be changed if you don't want to change.
hey, Mr. Pham,
Yeah.
so is that why on the Excel, every time you give us an Excel, is that the reason why you put down, you need a clock for each of those clock tests, correct?
Right. That means I want to change it, I must apply the one clock going 0 to 1.
Each and every time, right?
Right.
Okay. Each and every time.
Okay. So you understand it, you say your computer, you get 4 gigabyte memory. Okay, gigabyte 10 power of 9. 4 times 10 power of 9. Then you can get whatever number. Okay, then you multiply by 8 bit, you can get a very, very big number. So if you get a 2000 number, that means you get 2000 flip-flop inside. Each flip-flop can be stored only 1 bit. Okay? So memory basically just a 1 bit memory.
Sorry, could you repeat the last part? How many flip-flop for only 1 bit? One flip-flop, 1 bit.
Right.
Okay.
They get only 1 Q.
Well, okay, got it.
Now you want 16 bit, you got 16 flip-flop.
Okay.
Hey, you get 64 bit computer. That means you must be get 64 flip-flops.
Okay, got it.
Okay, that's the difference. Only the flip-flop inside your computer. You bought the computer, you must know what the frequency. Okay, that means how many gigahertz, megahertz. That clock will be controlled on off the flip-flop inside the motherboard.
Got it. Thank you, Mr. Pham.
However, engineering, when they design, they say, okay, I want to set the Q at the logic one anytime I want. So that's why they get another, not depend on the flip-flop. That will be a preset. Any flip-flop get the same. They must get that. And also they get another one we call clear. Okay? If they want to set output to get a logic one, they don't care what the clock in here. Then they just set this guy to 0.
Okay. So basically, add more degree of freedom having this preset and clear on that flip flop.
Yeah. On flip-flop must get that to input.
Okay, thank you.
I say, okay, now I want the output to be 0. I don't care the clock will be go up or down, whatever. Then I have to set this guy to 0. But this guy must be 1. Then output now 0 the way I want it. And for the clock in here, you apply the clock Q will be equal to D with the condition here. That means both this guy must be 1. If either equal 0, then they're not working with the clock signal. So when you understand that, you're able how to fix the problem. I given you example. Okay? You set the input here 1, and you get the clock going 0 to 1. And the output supposed to be a 1, but it's not. That's why you know how to troubleshoot it. First thing you have to make sure this must be 1. This must be 1. The thing is you're working on the clock. They must be 1. And the clock have to be going 0 to 1. That means you get the right input. You not get the right output here. Change the IC. This is not good. If you want to troubleshooting, very simple way. Make sure they get the right input, but they not get the right output. For this circuitry also, same thing. I get a 1 and 0 here, output must be 0. However, if they're not 0. I don't care what they do, they be, but they're not 0. Then your job will be go back to check on the B here. You take a DMM, you measure B here, make sure you get 0. If you get a 0, this means this guy not working. That is basically for troubleshooting. You get the right input, but you not get the right output.
Hey, Mr. Pham, real quick, one question. On the
Yeah.
clock, the only way we can check that is with the oscilloscope?
Yeah,
So you absolutely need a oscilloscope to check the clock.
yes, sir.
Okay, thank you.
The thing is, you take the clock, you can connect into that pin of the clock, okay? And when you run the program, and you can see they were 0 and now they jump to 1. That means the clock,
But you can't check the clock with a DMM.
no.
Okay,
So only thing you need a oscilloscope and DMM. If you know how to working with that equipment, you can do anything you want. Okay, so that is the D flip-flop we already talking to you. Okay, and if I say there's a D flip-flop here, they have a no bubble here. Okay, if they get a bubble here, that means the clock now will be going 1 to 0. Going this way. 1 to 0. Then Q will be equal to D. Negative going. Okay? And also, you get only 2 flip-flop, not much. When you're reading on this one here, okay, they given you the truth table, input, output. D equal 0 when the clock going 0 to 1. Here. Then Q equal 0. We're not talking about not Q. When D equal 1 and the clock going 0 to 1, Q equal to 1. And they draw that arrow clock transition low to high. And then another flip-flop, J and K. On this one, you get input J, input K. However, the clock now will be going high
Zero,
to low,
1 to 0.
1 to 0. So that's why when you're looking on this truth table here, J0, K0, when you get the clock high to low, output will be no change. You already know no change. It was 0, now they still be 0. Okay? It was 1, now still be 1. And J0, K1, when you get a clock going high to low, Q0, 1 here, and so on. And the last one equal 1, output will be toggle. That means it was 0, now they go to 1. It was 1, now they go to 0. However, my question is, when you're looking into the truth table, when you look into the truth table to find what Q equal, when? Who can answer that?
When J and K is different from 0 or 1, when they are different, basically.
Now, that's telling you difference between logic gate and the flip-flop. Right now, I'm talking about flip-flop. For example, JK flip-flop here. You want to know Q or not Q, you will be see the truth table.
Yeah. My point is, if you see the truth table, only you get information there when J and K are different each other. When both are 0, 0, there is no change in Q and not Q. And when they are 1 and 1, there is toggle. So the only way, the only moment that you need to get information from the truth table is when J is 0 and K is 1, or K is 0 and J is 1.
Actually, it's whenever the clock go from 0 to 1.
Okay, now I get J1, K0. My question is, when you will be looking into the table to know what Q or equal?
When the clock is going from 1 to 0.
Exactly, that is, you understand. You only looking in the truth table if the clock going high to low. Without this transition here, output will be no change. Either D flip-flop or JK flip-flop the same thing. D flip-flop the same thing. You get a 1 here, and if you want to know Q, only thing when you get the clock going from 0 to 1, then you can tell. You can tell what Q. Without that transition, output will be no change. And
So
you get only 2 flip-flop, not much.
Hey, Mr. Pham, so only like you and Michael said, you only look at the table when there's a transition of the clock.
Right.
Okay.
Must be at the, you get a transition. If you don't have a transition for the clock, output will be no change. Not much thing, right? Only two. That's why you can see that I see here. Okay? And also when you're looking into the diagram, you know what pin will be what. Pin 1, 2, 3, 4, 5, 6, 7. And the part number 74, 74. Inside one IC, they get two flip-flop. One here and one here. Okay? And also for the D, 16 pieces. Okay? That IC. And also you're looking into here, pin layout. And also two flip-flop inside. One here, one here. The power for this guy, not a pin 16. Pin 16 will be a K of the first flip-flop. Okay? The clock first flip-flop go to pin 1. Preset go pin 2. Q will be go to pin 15. And not Q go to pin 14. They're telling you all not the pin number. So when you build the circuitry, you know how to connect the wire.
So 5 is power and 13 is ground.
Yeah, 13 will be ground power pin number 5. When you build, this one will be saved for later. Okay, now, before we can stop, when the D flip-flop, they connect the wire from not Q back into D. They will be get a, they call a divide by 2. Divide by 2. What that mean? If you get a 1 kilohertz coming in here, 1K, output will be 0.5K. Divide by 2. Okay? This is the signal they gave it to you.
Mr.
Input, they just divide by 2.
And that's only happen when I connect the no
Yeah.
Q with T, right?
If you connect not Q back to D.
Okay, thank you.
Okay? So basically, you can testing the flip-flop in this case by 2 ways. You can connect the TTL signal into the clock and you measure the Q with the oscilloscope. If they 0.5K, in this case, they will be working. Otherwise, if you testing by a digital, that means every time you apply the clock going, then if it was 0, then now they will be 1, toggle. If it was 1, then now they be 0. Happen the same thing for JK. J and K tied together, tied to high. Also divide by 2. That means it was 0. Now you apply the clock. They go to 1, toggle. If you're looking at the truth table here, you see that? JK tied to 1. They will be toggle on the time when they get the clock. Okay? And you can testing either way. You apply the signal in here, 10 kilohertz. And you measure the output here will be 5K. Then they will be working. Okay? So now, whoever not done on the DLab 1 and 2, okay, try to do it, okay? You don't know how to do it, then try to let me know. You can on Zoom with me, I can help you out. If you cannot get it done, that means you really can be stay forever in the program. Even for the people already been here for almost a year, you're not done yet. Right now, I go to make a more simple for your guy to do it. If you're still not doing it, can you tell me what I can do? Okay? Don't ask me anything if you not get your job done. I said nothing for free. Okay? You get free for the program. We do the best, try to help you. You have to spend time to study. Okay?
No free ice cream cone?
That's it. No more.
All right, thanks, Mr. Pham.
Okay, no
Thank you,
problem.
Mr. Pham.
Yeah, no problem. If
Yes,
you
sir.
know how to do later on, I can guarantee you will be very, very excited to do this thing.
Finally, I understand the flip-flop.
Yeah, that's good. Okay.
Thank you. Thank you for that.
The thing is, after you know how to do what to do, and I teach you the way how to debug the program. When they fail, now what can we do? To
Just
fix the
don't
problem.
flip-flop.
Yeah, to fix the problem. Okay. I'm really interesting to teaching a digital, more logical. Okay. So we'll see you.
Okay,
Thank
thank you,
you.
Mr. Pham. Thank you.
You're welcome.